Hello, welcome again. We are covering GATE Aerospace Engineering Syllabus. Section 1 is Engineering Mathematics and the topic is calculus. And the subtopic we have covered just now is line cover. Now we will solve some question based on line cover. First question is um, if f is equal to 3xyi minus y square j, evaluate integral f dot dr, where c is the curve in xy plane. Y is equal to 2x square from 0 to 1 2. Okay, so as particle is moving in xy plane, so this r can be taken as r is equal to xi plus yj. This represents plane. Okay, as that is 0, so we take only two dimensions. So as r is xi plus yj, so dr will be of dxi plus dyj. Okay, and putting f this and dr as this and performing dot product for this line integral. So it will be 3xy dx minus y square dy. So as it is moving along a parabola whose equation is given as y is equal to 2x square. So we can put this y as 2x square here, here and here. Okay. So it will be 2x square here and 2x square whole square here and differential of 2x square here. And limits for x is 0 to 1. Okay, so now we need not this 0 to 2 because whole equation is in terms of x. Okay, so limits are 0 to 1. So now this will become 3 into 2, 6x cube, and this will become 2 into 2, 4, and 4x will come from here, and x4 is already there, so it will be 16x5. Okay. So now performing integration, it will be 6x4 by 4 and minus 16x6 by 6, and putting limit we get answer as minus 1/6. The next question, a vector field is given f is equal to sin yi plus x bracket 1 plus cos yj. Evaluate the line integral over a circular path given by x square plus y square is equal to a square and z is equal to 0. So here f is given sin yi plus x bracket 1 plus cos yj, and as it is circular path and equation of circular path is x square plus y square is equal to a square. So we can take r is equal to xi yj because this is also a plane. Okay, and dr is equal to dxi plus dyj. Okay. And for circular path, as this is the equation of the circle, so this a represents radius, and x can be written as a cos t and y can be written as a sin t, where t is the angle subtended with x axis. Okay, so now and this t will vary from 0 to pi because it is a circle. Okay, so now putting the value of f and dr and solving the dot product. So this is f, this is dr. So after solving it will be sin y dx and x 1 plus cos y dy. Okay. And further solving it, sin y dx, it will be x cos y dy, okay, plus x dy. Okay, so now this is a this is the reverse of the product rule. We take it as u and take this as b, then it will be then this as b, then in the reverse order it can be written as dx sin y. Okay. Taking it as u and taking x as b, it can be written as like this. Okay, and x dy is already here. Okay, so now we can substitute x and y and change and take the limit 0 to pi in terms of t. So x is your a cos t, y is your a sin t. Okay, and here again it is a cos t next is a cos t, and dy is your, we put y is equal to a sin t, and then differentiation of sin t is your cos t, and a is already there, so it should be a square cos square t dt. Okay. So now it's it is in differential form and we have to perform integration, so its integration will be this a cos t sin bracket a sin t, and limits are 2 pi to this. And to perform integration of this part, we'll take a square by 2, or we put cos square t as 1 plus cos 2t by 2. Okay. So and its integration will be a t plus sin 2t. Okay. And if we put limits in this, then it will become 0. So its integration is t plus sin 2t by 2, and if we put limit here, so we get answer as pi s. So next question is, find the work done in moving a particle in force field F is equal to 3x square I plus 2x z minus yj plus zk along a straight line from 0 0 0 to 213. B, curve defined by x square is equal to 4y, 3x square is equal to 8z from x is equal to 0 to x is equal to 2. So first of all, we will find out line integral. F is this quantity and this is your space, so dr is dxi plus dyj plus dz. Okay. So now performing dot product, it will be 3x square dx plus 2xz minus y dy plus z dt. Okay. So now solving first part, so as it is moving along straight line in the first part, from 0 0 0 to 213, so will form the equation of straight line. So equation of straight line passing through these 2 points is x minus 0 divided by 2 minus 0 plus y minus 0 divided by 1 minus 0, z minus 0 divided by 3 minus 0. So it is equal to t. So now x can be written in terms of t, that is 2t, y can be written as t, that is t, and z can be written as under the t, so this is 3t. So now we can put all the values in our equation. So x is 2t, so it will be 2t, and the differentiation dx will be 2 dt, so it will be 2 dt. And here there was 2x, so it will be 4t. Okay. And multiplied by y, sorry, z, so it will be 3t, and here divided by y, so it will be t. So and similarly here there was z, so it is 3t into 3 dt. So now the limits of t are 0 to 1, because y is equal to t, so it will be after integration we will get answer 16. So second part is, in the second part, x is equal to t, suppose x is equal to t, and relation between x and y, x and z is given. So we can take this, okay, and put here in terms of t, and put the limits of x as 0 to 2, okay, because x is varying from 0 to 2. So putting these values and in terms of t, we can solve this equation and find out answer as 6.